Hey, Randy here. Shall we make a game? And last time we re-implemented our sliding collision, but then when we tried it, we got this. The origin of the motion is over a wall of the navigation mesh. So what I need to do is have a quick look at thinking about it, it's actually probably more likely this code that's suspect, the code that actually applies it to the scene, than the collision code itself, because the code actually doing that check, if I bring it up, where is it? Not constrained to volume. Motion, here it is. This is actually really short. It's actually relatively simple, and the bit that's actually doing the collision check is pretty simple. I don't really see that being the bit that has the bug. So it's more likely the bug is in here. Let's read from the top. Let's try and imagine that we're coming in on the first frame and we're trying to figure out what this is going to do. So it's going to come in and it's going to see that it's the first frame because we don't have an active, we don't have a nav mesh. And it's going to get the location of the kind of cube from the model matrix. Okay, that should work. All right. It's then going to find the closest nav mesh component and face therein. That should work. And then it will get the navigation mesh out. That's fine. That should be good. And then it will constrain the location that we've just compared to the nav mesh, so it can't possibly be outside of the nav mesh at that point. Right. Next step. We then make a next coordinate, which is exactly the same as the previous coordinate. It's just it's down slightly, so you've got a bit of gravity, and we have our iteration loop. Okay. All right. We then perform the motion check. So what we're giving it here, let's just double check this. We're giving it the nav mesh, that should be fine, we've just set it. We're giving it the face, should be fine, we've just set it. We're giving it the previous and next location, they're fine. And we're giving it somewhere to put them, that should all be fine. Okay, so the question is, where's it going next? If it doesn't hit anything, then we just go, right, wherever you were going, you got there. You didn't hit anything, you're fine. If we hit the stop popping things up Visual Studio Code. If we hit the surface, then we take the sticky collision point and then we make it kind of like the start of the motion, and we take the sliding collision point and make that where it's going. Again, that sounds right to me. I don't see any problem with that at all. And then we actually compare. Hang on a second. We get the neighbor that we should be crossing over. So we have the edge number, we have the face number, that should be fine. And then if we did hit something, again, we do something similar to the surface up here. We basically take the sticky collision, make that the start point, and we take the sliding collision, make that the end point. But if, hang on, no, that's not what it's doing. It wasn't comparing the the face number to none. It was just saying if this is non-zero, which it is, so it would have hit this every time. Okay, what does this do? Still crashes, still crashes. Okay, all right, okay. All right, okay, so that will loop around and it'll keep going to run out of iterations, at which point it will constrain the destination to the current nav mesh face just so it can't escape, and then record that as next. Except I messed up. I made the same mistake here as well. Yeah, okay. That might explain it. If it's well, that causes all sorts of weird corruption. Okay, there we go. Okay, that's a bit weird. What is that doing? It's kind of not falling, is it? That's interesting. What's it doing? Okay. Is it hitting this path? I didn't import the header for that. Now I did. So, it doesn't think it's hitting a wall. Okay. Does it think it's hitting nothing? Yes, it does. Okay, so the next thing I'm going to do is I'm going to slow it down a lot. Like, let's slow it down 10 times. Let's see if A, it does the same thing. B, if we can tell what it's actually doing. Okay, so it looks like it's landing on the surface, and then the surface is kind of pushing it sideways for some reason. That doesn't sound right. So, yeah, in the event of hitting the surface, let me just, error. Yeah, that's right. So it's hitting the surface, and hitting the surface seems to be pushing it around a bit. So let's check in here. What happens when we hit the surface? So it should be grabbing the surface normal, grabbing the location of a vertex on the plane, doesn't matter which, that's fine. And then it's grabbing the distance, which again, that should be fine. Yeah, that should be fine. I mean, like it does seem to be kind of like actually doing something at the point at which I'd expect it to be hitting the ground. And then, what do we have here? We're interpolating between the origin and destination. And then hang on. And we're taking the destination, the difference to the point, which will be the correct one. And then we're checking that as a destination difference. We're then multiplying that by the collided normal, which again must be the right one. And then we're adding it. What? No, subtract. I mean, that still goes the wrong way, but let's have a look at this in Blender. What's actually happening here? Let's have a look at this triangle. View selected. Why would it be going right? That doesn't make any sense, does it? Let's have a look at it again. Okay, so just thinking. What could possibly cause what we just saw? Why would it be going sideways? I'm pretty sure the surface normal is right because it's colliding roughly the kind of altitude I would kind of expect. In fact, it's so good I'm almost suspicious. And the collision with the wall looks right, so I think this is probably right. Let's, as an experiment, let's actually going to select only this, invert selection, and then let's intentionally make something where it'll hit the wall first. So it's going to spawn like here, and then it should drop and hit this wall. Let's export it. Come on, build. What is that? Oh, what's it doing? Didn't expect that. Let me just draw this in Blender for a second. So let's say we have a wall like this, right? And we have an intersection like this. Now, we're calculating this here using that linear interpolation. We basically like calculated how long along this line we're colliding with the surface. And that seems to work fine. But what doesn't quite look right is this bit where it kind of goes this way. Now what we're doing here should be correct in that we are taking a point on this line, any point will do, and then we're taking the difference between this point and this point, right? Taking this. We are then dot producting it with this vector, which should get us the exact distance we are this way. Right? Right? Should do that. I wonder if I can actually skip this difference check because it's already, we already have, we're not going to try that. And then what are we doing? We are then multiplying this together to make a vector that takes us back to there and subtracting it. And that should be working. Okay, let's think of an extreme example. So like this, and you're coming here. No, it should basically never amplify motion. Okay, let's move the camera a bit closer, see if we can figure out what the heck's going on here. Let's move it 1 unit across, and negative is away from us. Let's move to say 2, and then maybe up slightly. Let's just see what happens. That is definitely moving sideways, and I have absolutely no idea why. Okay, let's lock it to 1 iteration, see if that helps. Okay, that behaves much more like we'd expect, although it still does weird stuff. I mean, it is still moving sideways. What happens if we increase the iteration count to say 100? Does it start moving more? Whoa, it really does. Okay, right. So yeah, we've definitely got some kind of like a cumulative error that every iteration makes worse. The other thing is though, is I wouldn't expect the iterations to really do anything here because if we have a triangle like this and we're dropping our object onto it like this, it should, in the first iteration, be making a motion like that. So it shouldn't actually collide more than twice. Interesting. Interesting. Let's have another look at this. Is there anything obviously wrong with this? It's definitely the surface that has an issue. So we're copying the iterated previous over to the previous and the iterated next to the next. And that should be right because in here we are calculating the exact point of impact and we are calculating the what the heck is going on here? Yeah, so we're calculating the exact point of impact and we're pasting that into the result origin and pasting it into the result destination. That should work shortly. That should surely work. Wait, hang on. Hang on, I see what the problem is. That isn't the collided normal. That is. So yeah, what was happening there was if I had this edge like, have this edge like this, it has a normal facing this way. And what I'm basically doing when the point crosses, I'm basically pushing it back to the surface. Except I wasn't using this, I was actually using this vector. Sorry, Actually, no, it would have been like from one of the corners. It would have been this vector. So it's just doing all sorts of weird and wacky stuff. Okay, does it do anything wacky at the edges? No. Okay, that's good. And we can probably knock the iterations down to like 5 and it won't make any difference. Okay, let's put the camera back where it was before. Ah, isn't source control a beautiful, beautiful thing? Let's undo all the mistakes I just made, and then I'm just going to put the nav mesh back in and do a build. Okay, so it should cross over that polygon. It did. It should cross into that polygon. Beautiful, 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 beautiful. And it should hit the edge and come to a stop. Well, it'll kind of slide down to the middle vertex if all goes well. Oh, that works beautifully, everyone. Oh, yes. Okay. So step 1 is I need to commit what I just did because it actually works. Fix motion. I don't know what else to call it really. Next one is we need to check this allows travel thing. So this is going to be, this shouldn't be too hard to check, I don't think. So I'm basically going to draw a, let's just speed this up actually just a touch. Where is it? There it is. Let's speed it up, say about 3.5 times. See how that looks. Okay, yeah. So I'm basically going to pick like an arbitrary point, like say there, or say there. I'm just going to make sure that, you know, I'm going to draw a line to it so we can see visually when it should be connecting. So we want to point, say like there, so that it'll be obscured by this edge, and then it'll be able to cross over into this, you know, cross over these edges, and then it'll eventually be obscured by this edge again. So by the time it's down there, yeah, okay, good. So let's just make a note of this point. Is there anywhere nice I can make? It's going to have to be here, really. This is kind of the wrong place to have rendering logic because the background will actually get drawn on top of it. Oh, and then I'll actually have the opportunity to, I could actually do the same thing with kind of testing I could start writing the actual navigation logic. Yes, there's one other major component of this I haven't really made a huge amount of progress on, which is the ability to kind of like, you know, reverse engineer a point on the screen into a point in 3D space. I started work on that and it's about 50% done, but it's kind of awkward to do. Because what I'm basically looking to do with that is to, because we have at the moment matrices that take kind of say model space to world space for, you know, objects in the scene, and an inverse one of those for the camera. However, what we actually want is a an inverse of all of those, and that's quite easy to calculate for. And in fact, I've already done it for the camera. That's easy to calculate for, say, the model matrix that places one in the scene. It's a little more complex to implement for. Don't go blank. Don't go blank. Don't go blank. It's a bit more complex to implement for a projection matrix, just because I don't actually quite have an understanding of what happens inside a projection matrix. I mean, it's simple enough. I just don't quite have it all in my head, you know. Okay, so what I'm going to do is I'm going to temporarily hack something around. I mean, who could see that coming? I'm going to take this advanced component thing and I'm going to put it there despite the fact it doesn't belong there to make sure it doesn't crash anything. And the reason is it just means I can draw a line from, I can draw a line in here just to demonstrate whether there's line of sight. So did I put that location in here somewhere? Target is going to be, let's grab these coordinates here. Okay, so now we have a start point, we have a target point. Again, just as like a temporary hack, I'm going to go into here and I'm going to steal this function I have for drawing a line. This might end up being a framework function eventually because it's so damn useful. All right, so we've got a static line. I think we've got everything we need in there. So we've got a model view projection, which is, how are we getting that? Oh, that's going to be a bit more difficult to get. Yeah, we'll just temporarily hack it so the camera exposes that, despite the fact it shouldn't. I think I've done this before a few times. Oh yeah, that's right. Okay, yeah, I remember this now. And then we're going to have one of those in here. And then rather than using this, we're actually going to use that global variable instead. Go! Oh yeah, I changed a header file. I should do a rebuild. So IE camera. I haven't got that camera header in here. Yeah, cameras are definitely going to become a component in their own right in future versions of the engine. We need to import the video buffer. Something else I was just thinking about as well was the moment that the fact that we have all these kind of like, you know, all these APIs, and all they basically all do, like all of them, with the exception of the one that advances game state, is they just return a pointer. And I'm like, given they already have a thing that returns a pointer to pointers, which is the state system, why don't I just use that for everything? Build. Oh, I haven't brought that in, have I? It will be in there, I think. And there we go. Now we have it drawing a line. That wasn't too difficult, was it? So next up, we need to call into our function down here, well, where we have this, and let's do our nav mesh check, i.e. nav mesh allows travel, and we should have a navigation mesh at this point. Yes, we do. Oh, we're also going to want to calculate the closest to the, yeah, okay, that's no problem. So we've got a navigation mesh, we have the current face, we have the current location, and then we have a target face, and we're going to have a target location. And if it allows travel, we'll make it green, otherwise we'll make it red. That should be simple enough. So we can ask for the closest surface on that nav mesh, nice and simple. and it's the target, and yeah, we just output to this new variable we're about to make with this target face. There we go. Okay. Let's see if that works. It's red. It's still red. Oh, it's green. And it goes red again. Okay. I think there might be a bit something slightly misleading there, because I think it might be. I'm just going to bring the camera in a bit and see if we can spot what's going on next. I think I know what's going on. I just want to verify it. Active object as camera. I suspect it might actually be because of the height difference. So let's just grab our coordinates from here, and then we can just punch these straight into this. Just zero these out, so we've got like a nice, even, easily translated value. Oh, I'm gonna have to have some adders for some helpers for like radians to degrees and vice versa as well, because having to convert these all the time is kind of annoying. Okay. Sometimes we get lucky with this and sometimes we don't. Today we're getting... I guess I put them the wrong way around. And that should give us a coordinate we can punch into there. And we should now see the camera kind of looking across it from the side. That seemed to activate significantly later than I would have expected. I suspect there's something wrong with that. So look, does it activate at the right point down there? See, I'd argue that end is fine. This end though looks a bit strange. Not entirely sure why it's saying that's not being navigable. Let's have a look. Let's have a look at the source code for it. Okay, so up to 64 iterations, that should be fine. If we've ended up with the right face, that's also fine. We have the number of vertices in the face. We have the locations, we have the exit normals. All great, all fine, no problem with that at all. Now this tolerance is very small and it actually extends triangles, doesn't shrink them, so it's not going to be that. Okay, so I'm going over it. We have the vertex location with the exit normal, that's all fine. We're then subtracting the location of the point we're testing from the vertex location. We're getting the difference, that's fine. And what's this location again? This is... Yeah, this is kind of like the start of the line, isn't it? Yeah. That's right, because the destination doesn't change, but the origin does. So, let's just think about this. Is it failing to, say, cross these edges? It is checking for the correct thing there, which wasn't... That was what was broken in any other functions. I'm surprised that works as well as it does. So we're going from the location to the destination location by closest distance. Okay, so yeah, we're basically pushing along that line based on where it intersects the face. So pushing over is the location. That's fine. That should all be good. So why isn't it? Are we resetting this between loops? Yes, we are. So that should be fine. Huh. Do we have anywhere else using the origin face? Just the opening. That's fine. That's fine. That makes sense. So I'm kind of curious. Is there a good way of indicating which exit we're taking here? I'm just. Can I just return like 1, 2, and 3 in here? Like, will it let me do that? Naught, 1, 2, and 3. It probably will, because I think Bull in the back end is actually just backed by, yeah, it's just an integer. Ah, beautiful. Okay, so next up, we can actually go through here, and we can actually go for a whole array of colors. So what we can do is something like this. Let's go for a whole spectrum. It's going to be red, yellow, green, cyan, whatever it is, blue, and magenta. And then we're just going to look up in the array using whatever we get out of that. And this should give us a color changing line that gives us the exact reason it left that function. So it's yellow. Or maybe it doesn't. Maybe the optimizer has done a thing or two there. Let's go to this. Let's go to this. Let's make it actually return an integer rather than just stuffing an integer into a bool and hoping for the best. Doing a parallel build because we've just changed a header file. I get the feeling this doesn't actually have a bug, it's just something that's, you know, a property I didn't previously realize about these nav meshes. So it turns cyan and turns back to yellow. And I think that yellow is going to be, hang on, it's going to be 1. So if I go into here, yeah, it's hitting a wall as far as it's concerned. Okay, so let's just double check it. Let's make sure that this is being set in the correct circumstances. Like, I bet if I turn the iterations down to like 1, we could probably make it go a different color. Yes, that's red because it's what's 0 mean again? It's 0 means it ran out of iterations. So I think this triangle has like a split. Yeah, it does. So yeah, it's running out of iterations, then it's hitting a wall, and then it's running out of iterations. And yeah, okay, so that part of it seems to work nicely. Okay, so what's the next problem we can kind of deal with here? What's the next possible place this could be wrong? So destination difference is the destination location versus the vertex we're colliding with. And the origin difference is the location that we're kind of carrying with us across the nav mesh. Let's say here. I'm just gonna build it again. Just watch this gonna work. Yeah, it's changing color like way after it crosses that, after it reaches past that. So this definitely feels like there's something wrong here. Something off about this. It doesn't quite feel right. So, What could be wrong with this? What could be the cause of our ills? Yeah, that's the kind of like double inversion tricks. That's fine. That should be fine. So we're comparing against the exit normal. That's right. Destination difference. That's location, destination, and location. That's fine. And we're not reusing all of these further down than we should. Nope, that's fine. Huh. I'm not quite sure I understand what's happening here. This doesn't look right at all. Hmm. Huh. Hmm. We're not using one of these in the wrong place, are we? Nope, that looks good. And that looks good. Huh. Trying to figure out what's special about the point at which it starts working. Is this something that happens differently at that point? Okay, I'm going to try something else as an experiment. I have a sneaking suspicion that our problem is that it's for whatever reason not able to get across this line. So let's turn this into a quad, even if it isn't really one. And let's also slow down the motion slightly. It's a bit too fast. I really want to be able to see the exact point at which it switches on and off. Okay, let's have a look. Oh, it crashed. Tasty. All right. So the origin of the travel check. Now, this isn't very planar at the minute, but I'd still not really expect that to even be possible. How would that happen? Can it happen in a single iteration? That's a question. No, it cannot. So let's go back into here and let's figure out which iteration it's failing on. Now, there are better ways to debug things, write out debug messages to the console. Through many of my own poor decisions, none of them are available to me. So let's have a look at this. Okay, come on, tell me where I've gone wrong. Come on. 1. Okay, so this is after a single iteration. So it'll have crossed this line and got to here. And is that convex? That doesn't look very convex, does it? I think that's the issue. I think it's not convex. Fine, I'll drag it this way slightly and see if we can still reproduce the issue. I think that's convex. I think it is. I believe it's convex anyway. How about that? Should we also try and flatten it out just a touch? None of this is like strictly correct, but it should be giving us like a reasonable idea of like whether this is going to work in the real world. I guess if I have geometric issues, that might explain why it's acting a bit strange. Let's have a look. There we go. That's changed significantly. Again, it's activating like way later than I would have expected. Why? Why is it activating so late? Like, it's definitely clear of this edge by the time it's kind of accepting its fate. How strange. What the heck is going on there? So I guess I can put some more debugging stuff in here and I can kind of like draw the points where it's kind of crossing edges. So I guess I could do that here. I think, yeah, so I've got static line. Okay, that's good. So let's draw some, It's gonna be annoying is that the, So I'm just thinking out loud here, as I usually do. What's going to be annoying is that we're going to be drawing a line immediately after this function that kind of scores over the top of it. So I have to draw something that's actually visible. Static line. Or I could just turn that off for a second just so I can see what I'm doing. Like that. And oh, actually no, I'll leave that in. I'll leave that in. Okay. So we're deep in Hackerville now, lads. I'm going to set this to the location. And we're going to have two of these, one to the left, one to the right. And we can then kind of like rotate it around and get the ones above and below. But this is probably good enough for a start. So we're going to draw from, oh yeah, we need the camera's position as well. Ah! God, have we nearly finished the stream already? This is ridiculous. I'm getting nothing done. Ah! Okay. View projection, we're going to need the video buffer again. We're going to need the origin location, which is temp A. We're going to need the color, which is going to be, what haven't we used here? Let's go with blue on both ends. And I wonder if there's any kind of like anything to be said for kind of like just having one massive header file for your entire project, because you have to recompile the whole thing anyway. I wonder if it's just compilation time really that makes it make sense to keep them split up. And let's bring in the video buffer as well. So that's in API video buffer. There we go, got it. Oh, didn't like that. Because I used the wrong, I'm still using the wrong prefix from when I started this project. Ah! Okay, we're going to see some line crossing action. No, I guess we're not. I mean, this might explain why we've got a bug if we can't see. Oh, there it is. There's the line crossing. That looks like it's in the wrong. Oh no, that's crossing that edge there. That's fine. And that looks like it's crossing in the wrong. Hang on a second. Hang on a second. Hang on. Let me just get this. This might actually be correct what it's currently doing. I just need to verify this. So we need to add a new vertex, and we need to place it at there by there by there. Right, part of the reason this looked kind of strange is that technically, because the kind of like line of sight thing ignores kind of the surface, it's actually kind of traveling underneath the surface here, which does look a bit odd, and I'm wondering if that might be having some kind of impact on how it's kind of progress through the terrain is being considered. Let me just switch up my tunes here so I can keep going. There we go. Let's have the other axes and see if they're see if something pops out of this then. Yeah, I'm definitely going to have to make this a library function of some kind. It's just so useful. Oops, I'm not actually using these things I just made. Ah! I thought this was going to take 3 or 4 days to build this entire nav mesh system. I was not anticipating it taking 2 weeks and still not being done. Okay, that's kind of interesting. Why is it doing like that weird slide? It's kind of like sliding along the length of the line. Yeah, something's definitely not right there. So it looks kind of right there. But that doesn't look right. Doesn't look right at all. Hang on a second. Hang on a second. No, that should be pretty straight up there. What I was considering was what if the let's draw this. Remember, I'm kind of looking at it this way. So we've got like this. We're at the point where it starts here, and then we've got kind of like this vertex here. I was wondering, is it possible that there's kind of like a collision plane like that? But it wouldn't be. It would actually be the other way around and be like that. So it doesn't make any sense. Okay, let's temporarily put the camera back where it was, or let's actually put it into a different spot. Active object as camera. Yep, good. And then let's comment these, I think. Side on, close up. Okay. What the heck is this doing? It just doesn't look right at all. I'm sure this is just like a manifestation of kind of like all these kind of like slightly abstract concepts doing just things I didn't quite expect. But it looks like a bug. So it might be a bug. And it's the kind of subtle bug that probably adds up to like big kind of like glitches later on. So I want to get it nipped in the bud now, if it is a bug. Not doing this kind of thing is actually part of the reason why one of my earlier attempts at this went a bit wrong. Yeah, that's definitely doing something a bit strange. What is that doing? Okay, so let's go back to here and let's actually put this in here as well. Just so that we're getting a bit of a view on when it's hitting walls. Just so we can get like a real idea of what's going on here, because I suspect it thinks it's crossing kind of like to the north, and I suspect, get this view. Yep, select it, please. I suspect it's crossing over into this face and then kind of hitting this wall. Huh. How weird is that? Let me just put the camera back to side on. See, the normal of that there should be going kind of like that. So it should, if anything, actually be, it should be getting out the way of this wall sooner than you'd expect, not later. How mysterious. Hmm. 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 Huh. You know what I'm going to do? Once I've had just another quick little cursor read over this to see if there's anything super obvious I can see that I've done wrong. I'm going to see about snapping this line to the kind of like to the tiles, just so that we don't get situations like this where we're kind of like crossing underneath polygons. Because I think crossing over the top of them, like say if we had like a valley like this, and you were trying to work if you can get to there, and it kind of like cross this line up here, that's fine. I think that actually kind of makes sense. It's just in the opposite case where kind of like you have a hill, and you're trying to get from here to here, and it ends up like trying to cross this underneath the ground. Doesn't quite make sense. Doesn't quite look right. So this shouldn't be that hard to do though. He says. Yeah, okay, so hang on, I'm thinking. Ow, 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 ow. Yeah, we need to get the surface normal the first polygon and project the start point onto it. And then each time we iterate, we project the end point onto the surface of the current polygon. Yeah, that'll work. That'll work. Actually, just every time we cross into a new yeah, let me put a note in here. To do project destination onto surface of new polygon. And the same here. To do project origin and destination onto surface of new polygon. In theory, once you project the origin once, as long as the destination is projected, it can never leave because it's always going to be at the crossing point. I'm hoping this clears it up anyway when I've implemented this. How long have we got? We've got like 10 minutes, whatever. We'll do it. So do we have a difference in here already? Yeah, I've already got origin and destination difference, so I'm going to reuse those up here. And let's put them all in one line, why not? I'm feeling like saving some lines. Okay, so let's get the surface normal, which yeah, so we've got the face, we've got that. And we're going to want to get our first surface normal. And that's just basically going to be a pointer into the surface normals based on the face number multiplied by 3 as a free axis per surface normal. And then we calculate the, do you have a multiplied normal in here? No, we don't. So I'll make one of those two. Yeah, I can get that. So yeah, we're going to do a standard kind of like projection thing here where we are subtracting the origin location from any vertex on the face face. So that will do face, and it's going to be vertex locations. First vertex location, we don't care at all which one it is we end up with, as long as it's a vertex location. Yep, and then we are comparing that to the first vertex location. There are 3 axes, and then we're writing it to the origin difference. Yep, that's nice and simple. And we're doing the same for the destination location. And we're going to need a current origin location and a current origin destination. Sorry, current destination location. Because we're going to be tracking both of them. Okay, so then we've got the destination difference. Easy. We're then going to be doing a dot product with the first surface normal and the origin difference and 3 axes. And we're going to be subtracting the, hang on, we're going to be multiplying a vector by scalar. So we're going to be multiplying the first surface normal by the dot product which produced 3, and it's going to be a multiplied normal. And we subtract the multiplied normal from the origin location. Yep, which gets us the current origin location. And we do almost the exact same thing with the destination, and that gets us the current destination location. Okay. All right, okay. And then rather than using location, what was this again? This was the, oh, that was the current origin. And then what do we have here? We have the destination location, which is the current destination location. Okay, and then down here we have the current origin and the current destination. And that should then produce our current origin location in both cases. And then we just need to basically repeat this step up here where we're basically projecting it onto the surface. But we only need to do it for the destination this time around. So let's go down here. Oh, I've made a mess here, haven't I? Okay, so these are all just going to be current origin location, I think. I think that'll do for all of these. And then if we're crossing an edge, this is where we need to project the destination onto the new surface. So that's where we need to basically take this code up here, and we just need to cut it down a bit to only do the origin and to use to only do the destination, not the origin, sorry. And so origin, you can go, you can go, you can go. And first 6 locations, that's fine. Okay, and then rather than calculating all this with the destination location, we're doing it with the current destination location. Let's see what that does. Let's see if that works. Let's see if that even compiles, because I am doubtful, honestly. Okay, let's see if this does something a bit more rational than what we had before. No, it's doing the same thing. That's kind of interesting. I wonder what it's doing and why. Because I wasn't necessarily expecting that to actually fix the problem. I was just kind of curious to know if it would. I wonder, is this actually failing to cross into this? Hang on. Let's go into here. Let's see if we can prove that it's actually crossing at the right time. So here we are. Okay, so now we're going to look at the second node mesh. And we're going to look at the vertex counts, and we're going to look at the one we've just swapped into. If it's, we're expecting 5, aren't we? Let me check that's a 5-sided polygon. It is 1, 2, 3, 4, 5. Yep. If it's 5, then we're going to throw an error going, yep, it's 5. I suspect our actual problem here might be with our collision. Okay, come on. Okay, nope. It does actually cross over correctly at the right time. Okay. Well, scrap that theory then. So, the problem is that for some reason, it seems to think that this line from here to here is running along this edge. Why would it in what situation would it possibly think that's the case? Next step, let's verify that the kind of projected points are correct. So it's going to be similar to all this, except it's going to go like way up here. And we're going to verify that the kind of like points it generates at kind of, the first one it puts down. We'll make sure that's correct. Just going to make it green so it's visually distinct from the other ones. Oops. Is it going to have a problem with me shadowing a variable? I don't know. Maybe. Nope, it doesn't care. Okay. Right, so it is projecting the point onto the line. Nice. But why is it seeing it's intersecting this? I just don't get that. I just don't get that at all. Okay, next step. Next we need to check is the... where's that gone? There it is. Let's check that the destination that we're projecting onto the surface is correct as well. Because I don't know if it is. I mean, I would expect it to be. But it's not entirely possible that it's like flying off into space or something if we've got the wrong... if we're doing the wrong math or something. Why is it there? I mean, this bit being a bit up in the air I get, but that was weird. Anyway, that doesn't seem to explain what we're just seeing. Let's go have a bit of a read over this and just make sure it still makes sense to me. Got destination location, which is what's been passed in. We're getting the difference between that one and any point on the face. We're then running to the destination difference. We're then dot producting that with the surface normal to get some multiplied normal, but then adding that to get that. So that should be fine. Why on earth? Why on earth does it think that the line from there to there is running along that edge? That just doesn't make any sense to me at all. So I guess the next thing I need to do is I just need to check the distance calculation because in theory, it probably is eventually hitting that edge, but it should be hitting this one first, is the thing. So let's have a look here. So this is our loop. We're going through all of the vertices in the face. That's fine. We have pointed to the locations of the vertices in the face. That's fine. We're getting the vertex location using that. Again, that's completely fine. Face exit normal. Again, that looks good. We are definitely using the right list. That's good. We're definitely not using the say the first one on the face or something like that. And then doing a dot product, makes it normal. So yeah, that should be working. I can't really afford to spend much more time on this, but I want to know why this doesn't work. Yeah, what let's do. So like, I'm just going to explain what all these things on the screen mean. So these kind of like polygons are the nav mesh structure, right? It's basically like a model in space that represents where the kind of player can go. And I'm basically trying to figure out if there's line of sight between the player, represented by this kind of cube, and this random point over here. And so if I bring the kind of Blender sort of file up, we're kind of running down this face here, and the destination's over here. So you can imagine the line kind of looks something like that, vaguely, give or take. Now, it seems to think that the point is being like projected along this edge for a lot longer than it should be. Because just looking at that, I mean, like, again, I don't know if this is wrong or not, but like, I guess looking at like in here, I can see that it would actually run along the edge. It would actually kind of run along the edge like that. You can see like the kind of like intersection point kind of runs from right to left. But it just seems extremely late. It seems like you have to come a lot further down here than I would have expected before the it counts as having crossed over that edge. Like the line has not just crossed a little bit, it's crossed the line a lot before it actually counts as being kind of in the clear. And I'm really confused as to how that's even possible. So yeah, the red kind of cross indicates where it's kind of like hit a wall in the nav mesh, and it's considering that to be, you know, out of line of sight. And anything blue is where it's crossing a tile. Just don't get it. Why is it? In fact, this red cross isn't very well synced with the line either. I would have expected that line and that red cross to sync up perfectly, but they don't. It's kind of interesting. I'm going to remove this code to project onto the surface because I didn't think it was necessary in the first place. It doesn't seem to be actually solving the problem. Get rid of that. And this can go here. And then I'm going to do a vector copy from the origin location to the current origin location, which is not defined by this point. Great job, mate. Okay, let's have a look at how that looks. Does that make it? Oops. We've got here, got the vertex location, it's never used, that's fine. And surface normal, it's never used. Again, that's fine, doesn't matter at all. Unused variable surface normals, that's fine. Where is it? Where is it? Where is it? There it is. And multiplied normal, also never used. That's fine too. That doesn't matter really. So again, this is actually going to have like an almost identical outcome, right? Yeah. Ah. Although it is doing a better job of tracking the line. Huh. I don't know. I guess it must be correct because I can't find any kind of like... It looks weird that, you know, like it's crossing this line before it's counting as having got there, but I guess it must be right. I guess what it must be doing is because if you bring it down here, it's like there. Hang on. Let's just go into wireframe mode. See if we can figure and we can also use the face project snap in Blender to figure out. Yeah, so if we take it to say there, the point at which it kind of looks like it should be crossing the line. It actually might not be. It's actually, oh, that's what the issue is, I think. Yeah. Hang on. At that point, it's not right. Okay, when you look at it, when you're looking at it from this angle, which is where I put the camera, it looks like it should be crossing the line. But when you actually look at it from above, when you look at it from the perspective of kind of like, yeah, the polygons, it's actually still crossing this line. That's kind of what's happening, I guess. And does it get more extreme when you kind of like, the further you roll this way? So yeah, it was basically all in my head. It actually worked fine. It was just all in my head. So again, like if it's here, it's actually there. Ah! Ah, there was no bug. There was no bug this entire time. Okay, let's clean this up a bit because I've made a right mess of this trying to figure out why on earth it doesn't work. And then we'll call it a night. So do a bit of a clean up on this. This shouldn't have any of this in it. And this should be a false. And this should be a false. I think. Hang on. Let's have a look at the original code. Don't need any of that. Yep, that should be a false. And in fact, I'm having a look at this and I can't see any improvements I've actually made in the last like half an hour spent trying to figure out why this has a bug that doesn't exist. Ah! Okay, let's make that again, and let's just make sure that it does something that at least looks rational. I think the other thing was, I've got the bit in here where it goes for the colors. Oh, I've changed the header file. I should have done a rebuild. Oh, I've crashed the terminal. No, no, no. It's all going great, just in case you're wondering. Do a parallel build, and I think I call it travel. Yep, I did. Okay, so at this point, it should just change color as it kind of crosses the aperture. Yeah, okay. And yeah, it looks wrong, but it's actually right. Well, lesson learned, I guess. Anyway, I hope your evening's less confusing, and you have a good one. See you another time.